Hi, I am Fatima binti Abdul Rahman, as the leader of this group.
Hi, my name is Damian Fakihah binti Muhammad Talha.
Hi, my name is Putri Sadatunisha binti Yahya. Okay, so first I will introduce you about our program. This program is an online flight ticket booking system for users who want to buy flight tickets online instead of queuing at the counter. The main objective of this system is to provide a convenient and seamless booking experience for customers and employees. This is because booking flight tickets can be stressful for many customers, especially first-time users. In this project, there are three main objectives that we want to achieve. First of all is to design a user-friendly booking system that allows customers to select and manage their travel preference. Second, to calculate the total flight ticket price based on passenger category, seat class, trip type, and number of tickets. And lastly, to display the booking summary and generate a receipt for customer.
Hi, I am Balkis and I will be presenting the use case diagram for our online flight ticket booking system. Based on this diagram, we have one main actor which is the user. The system flows with the login process. User can search for a flight via the search flight function before proceeding to the book flight. Here, the book flight process has an include relationship that requires the user to select a flight and enter passenger details. Next, the make payment process also includes a select payment method function before the transaction is completed. Finally, after the payment is successful, the system allows users to perform management activities such as generate receipt, view ticket, view booking history, and user can even cancel booking if necessary. All of these use cases are designed in line with the methods found in our class diagram. That's all from me. Thank you.
Next, we will move to UML class diagram. First, a user logs into the system. A single user can create multiple bookings over time, but each booking belongs to just one user. Next, a booking structurally aggregates two critical components, which is flights and passengers. Because this is an aggregation relationship, flight and passengers profile can exist independently in our database, even if a specific booking is cancelled. The booking class manages this data, calculating totals and handling confirmation. Once a booking is successfully confirmed, the system triggers two simultaneous workflows, which is ticketing and payment. On the ticketing side, a booking can generate multiple individual tickets, typically one per passenger, which handle boarding pass generation. On the payment side, each booking links directly to exactly one payment transaction. Once validated, that payment generates a unique itemized receipt. Finally, to make our system flexible, we use inheritance for our payment processing. Payment acts as generate parent class, which branches out into two specialized payment methods: wallet, which supports QR code generation, and credit card, which handles traditional authorization and card masking for security. Moving on to the user class, this handles the account profiles of the customers using our platforms. The attributes it stores credentials securely using private attributes for the customer ID, email, and passwords. It provides access to its data via standard getters and setters. For the method, login method to simulate authentication. The logout method handles the termination of a user's active session. View booking history method to pull up past trips. Finally, toString method is overridden to cleanly display the customer's ID and email without exposing sensitive details like their password. Next is the passenger class, which acts as a data container for individual travelers' profile linked to a booking. Attribute stores unique passenger information privately, including their name, passport number, assigned seat number, nationality, and age. What makes this class vital are its conditional validation methods. Get age group methods evaluates the passenger's age to categorize them as a child, senior, or adult. Similarly, its minor method returns a boolean confirming if the traveler is under 18. These are critical for enforcing airline safety, compliance, and ticket pricing regulations. Finally, toString method formats and display a comprehensive profile summary. Next is the flight class, which serves as a data blueprint for any flight in our system. The attribute encapsulates all the essential flight information as private variables, including the flight ID, route details like origin and destination, scheduling times, rating available seats, and the ticket price. Standard getters and setters provide secure access to these private variables. Finally, it includes core method like check availability, which simply checks if available seats are greater than 0. search flight method to simulate querying the flight database, and toString method to cleanly print the entire flight itinerary for the user.
Last booking, I have kept data like booking ref, booking date, status, flight details, passenger count, user details, and payment details. Here we implement encapsulation by using private variable with getter and setter method to protect the data. We also implement toString method to easily print out and display all the complete booking details in one go. For the first method, we have add passenger method where it will check if there is still an available slot for the passenger. If yes, it will add the passenger to the count. Otherwise, it will display a max passenger limit has reached. Next, we have the calculate total method to calculate the total expense. It will return the price from the flight multiplied by the passenger count to get the total amount. Lastly, we have confirm booking and cancel booking methods, which will basically display whether the booking has been already confirmed or will be cancelled. Moving on the ticket class, it is used to generate the boarding pass for the passenger. Just like before, I have also implemented encapsulation here by using private variables with getter and setter method to secure the ticket data. Inside this class, I keep attributes like ticket number, PNR number, status, and booking details. For the display, I implement two methods. First, toString method to return the complete raw data of the ticket for system checking, and second, a boarding pass method, which will format and print out a clean, user-friendly layout, just like a real boarding pass for the passenger. Lastly, I include validate ticket method. Its function is to check if the ticket is still valid. For example, by making sure the booking status is already confirmed before a user can board in.
This is payment class. We have two attributes in this class, which is transaction ID and amount. In this class, we have a default constructor and a normal constructor. After that, getter and setter methods are used to update the payment details. And then the validate transaction method to check whether the payment amount is valid or not. And lastly, toString method to display the payment information. This is receipt class. We have 7 attributes, which is receipt number, payment ID, booking reference, customer email, transaction date, total amount paid, and payment method. In this class, we have two constructors, which is default and a normal constructor, and then the setter and getter methods to update the receipt information. Besides that, we have a method such as print receipt to print a receipt, and an email receipt to send the receipt to the customer email. Lastly, we have toString method to display all receipt details in this receipt class.
Lastly, for the main class flight ticket main, this is the entry point of our application. I can divide this main method into 3 main phases. First is the data info phase, where we use JavaScript to get information from the user, including user account details, flight information, and passenger details. Second is the logic and validation phase. Here, the system will check availability based on the number of passengers requested. It then triggers the add passenger method and generates the ticket boarding pass. Third is the file input-output phase for data persistence. We use buffer writer to save the final booking record dynamically into a booking.txt file. Right after that, we use buffer reader to read the text file back and display the saved booking details directly on the console. That concludes our presentation for this incomplete yet functional online flight booking ticket system. That's all from us. Thank you.